IP address. An IP address is a unique set of number that is used to identify a device on a public or private network. IP stands for Internet Protocol. So IP address is Internet Protocol address. It is the set of rules governing the format of data sent through a network. Therefore, IP addresses are the unique recognition of all devices across the private as well as public network. There are two types of addresses, IPv6 and IPv4. Let us discuss about IPv4 addresses, which are commonly known to us as 32-bit numbers presented in dot decimal notation, and it is separated by 4 octet places. Each octet place holds 8 bits, or you can say 1 byte, as because we know 8 bits equals to 1 byte. As we know, computer can only understand zeros and ones, but we find easy to work with the decimal numbers. Therefore, we provide the decimal numbers as the 32-bit IP address, but the computer will convert those into zeros and ones in those places. Now let us understand what is the minimum and maximum number that we can provide as the valid IP addresses. Each octet has 8 bits, and each of those bits can hold ones, that is 8 1. This is the maximum value for each octet place, and it can hold all zeros, that is 8 zeros. This is the minimum value for each octet place. If we convert the value of 8 ones into the decimal number, then it will be 255, and if we convert the value of 8 zeros into decimal number, then the result will be only 0. Here the minimum number that can be assigned as the octet value is 0, and the maximum octet value that can be assigned is 255 in each octet. That is the range between 0 to 255. So total 256 combinations. The combination of zeros and ones in each octet place can be of any type. 01001101 decimal value results to 77. 00001111 decimal value results to 15. 11001111 decimal value results to 207. 11110000 decimal value results to 240, and so on. The 32-bit address contains two primary parts. The first one is network number and the second is host number. All host devices within a single network share the same network addressing number, but each and every host are recognized in the network by unique host addressing number. Now let us discuss about IPv6. It is 128-bit numbers used to identify and locate a network interface of a computer or a network node participating in a network. IPv6 comes into existence in the purpose to take over and replace IPv4 protocol, because in IPv4 addressing there can be the maximum of 4 billion IP addresses that will be assigned to the networking devices across the public network over the world. Therefore, it is to be expected that the IPv4 will be exhausted soon, and then IPv6 will come to use, whose capacity of addressing IP addresses is just huge in compare to the IPv4. If we assign thousands of IP addresses per second, then it will take billions of years to consume just 1% of total addressing capacity. Now we will discuss about IP address classes. There are 5 classes of IP address defined in TCP IP: class A, B, C, D and E. Each class has a range of valid IP addresses, and the value of the first octet determines which class this IP address is belonging to. The first 3 classes A, B and C can be used for host addressing. Class D addresses are used for multicast routing. Class E IP addresses are kept reserved for experimental and research purpose. Class A IP address range start from 0.0.0.0 to 127.255.255.255. The first octet place holds the network number, and the rest 3 octets holds the host numbers. That is why class A is defined as 8-bit address. Let us give an example of class A IP address: 10.23.45.22. This is 8-bit address because the first octet holds the network value, that is 10, and the rest 3 octet holds the host value, that is 23.45.22. Therefore we can have only 128, that is 2 to the power 8 minus 1, that is equals to 2 to the power 7 possible networks in class A category of IP address, because 1 bit out of 8 bits is kept reserved for identification of network category, and 1677216, that is 2 to the power 24 hosts in each of the class A category network. That is why we can configure huge host number in class A category network. Class B IP range start from 128.0.0.0 to 191.255.255.255. The first and second octet places hold the network number, and the rest 2 octet holds the host numbers. That is why class B is defined as 16-bit address. Let us give an example of class B IP address: 130.120.140.24. This is 16-bit address because the first and second octets hold the network value, that is 130.120, and the rest 2 octets hold the host value, that is 140.24. Therefore we can have 16,384, that is 2 to the power 16 minus 2 equals to 2 to the power 14 possible networks in class B category IP address, because 2 bits out of 16 bits is kept reserved for identification of network category, and 65,536, that is 2 to the power 16 hosts in each of the class B category network. Class C IP range start from 192.0.0.0 to 223.255.255.255. The first 3 octet places hold the network number, and the last octet holds the host number. That is why class C is defined as 24-bit address. Let us give an example of class C IP address: 198.160.10.12. This is 24-bit addresses because the first 3 octets hold the network value, that is 198.160.10, and the last octet holds the host value, that is 12. Therefore, we can have 2097152, that is 2 to the power 24 minus 3 equals to 2 to the power 21 possible networks in class C category of IP addresses, because 3 bits out of 24 bits is kept reserved for identification of network category, and 254, that is 2 to the power 8 equals to 256 minus 2 equal to 254 hosts in each of the class C category network, because among the number of hosts, first number, that is 0, will be used as network ID, and the last number, that is 255, will be used as the broadcast ID. Therefore, in class C category, we can have maximum number of network configuration, but very limited minimum number of hosts in each network, that is only 254 hosts per network in class C category. IP range of class D start from 224.0.0.0 to 239.255.255.255. Class E IP range start from 240.0.0.0 to 255.255.255.255. 127.0.0.0 belongs to class A category, which is used for the internet host loopback address, a datagram sent by a higher level protocol to an address anywhere within this block should loop back inside the host. It is often used by the command localhost at our system browser to access our own resources of the device accessibility. Let us discuss about subnetwork. The subnetwork or subnet is the most important component of an IP address. It is the logical subdivision of IP network addresses. So, it is the practice of dividing a single network into 2 or more networks. Subnet mask is a 32-bit number that is created by setting host bits to all zeros and network bits to all ones. In this way, the subnet mask separates the IP address into the host part and network part. The word mask has significant value because the subnet mask essentially uses its own 32-bit number to mask the IP address. The default subnet of class A category network is 255.0.0.0. There are 4 octets in this 32-bit number, and the first octet is addressing to the network value which holds 8 ones, and the rest 3 octets is addressing to the host values by holding zeros in 3 octets. Each octet holds 8 zeros. The default subnet of class B category network is 255.255.0.0. Therefore, 4 octets in this 32-bit number, and the first 2 octets is addressing to the network value which holds 8 plus 8 16 ones, and the rest 2 octet is addressing to the host values by holding all zeros, that is 8 plus 8 16 zeros. The default subnet of class C category network is 255.255.255.0. There are 4 octets in this 32-bit number, and the first 3 octets is addressing to the network value which holds all ones, that is 8 plus 8 plus 8, 24 ones, and the last octet is addressing to the host values by holding 8 zeros. Now let us discuss about public IP address. Public IP address are global address that is used on the internet to identify a networking device. One device having a public IP address can access another device across the internet having the unique public IP address. There are a limited number of public IP addresses which are reserved for use and identify devices across the public network. Now let us discuss about private IP address. Private IP address are local or internal addresses that are assigned to the devices of an organization for the purpose of internal communication among different devices. The private IP addresses those are assigned to one organization can be same as the IP addresses assigned to another organization, but there will be no ambiguity to identify those devices uniquely because private IP addresses are only restricted its uses inside the organization. Private IP addresses will never going to communicate with the public IP addresses, and the private IP addresses of one organization cannot communicate with the private IP addresses of another organization. Therefore, on behalf of all private IP addresses of an organization, a single public IP address can communicate across the public network, that is over the internet, through a specific process known as NAT, that is network address translation, by using some devices that we will discuss in another lecture. Now let us discuss about network ID. Let us understand the network ID. It is the first value of host space that is identified as network ID. It is the portion of TCP/IP address which identifies the network for a given host, and it is used by router in order to find a network. Now let us discuss about the broadcast ID. Broadcast ID is the last number after all host numbers that is used by nodes as a destination address when they want to send a broadcast request for transmitting a message to all devices connected to a communications network. Then it is received by all hosts connected to a network.